Welcome. So in this lesson, we're going to be talking about reflections. Now, reflections come in two types. You have a reflection in the x-axis and you have a reflection in the y-axis. Let's begin by looking at reflections in the x-axis. So right here, let me grab my pen. Right here, we have a 0.22. If I were to reflect this in the x-axis, so remember this here is my x-axis, what would end up happening is my point would be here. So the coordinate of this would be 2, -2. So which value changed, my x or my y value? Well, quite clearly, my y value changed when I reflected in my x-axis. So as you can see here, here is my original point, here is my new point, and y dash is equal to -y. So therefore my answer is 2, -2. So this is yet again similar to dilations, in which when you're doing something in the x-axis, it changes your y value. So very important for you to know that when you're reflecting in the x-axis, it's your y value that changes. And if we were now to look at a graph as opposed to just a single point, a reflection in the x-axis can be defined by the rule this. And as you can see, this is my original graph, and once I have reflected it in the x-axis, it now exists down there. Whoops, it exists down here. And as you can see, it's not my x value that changes, rather it is my y value that changes, which is very important. Let's now look at the other type of reflection, which is a reflection in the y-axis. So if we look here for a moment, let me just move this over here. If we look here, I have a point at 2, 2. If I were to reflect this in my y-axis, so remember this here is my y-axis, it would come over here. And the coordinate of this point would be -2, 2. So as you can see, it's my x value that changes when I reflect in my y-axis. So as you can see here, x dash is equal to negative x. So that's very important. If we were now to look at a graph here, so a reflection in the y-axis can be defined by the rule this. This is my original, and once I have reflected it in my y-axis, it now looks like that. So it's very important to know what it looks like when you reflect in your y-axis. All right. Let's now just fill out this table as we have been doing. So the type of transformation that we're looking at is a reflection. When we're reflecting in the x-axis, that means my x dash is just x and my y dash is -y. When I'm reflecting in the y-axis, my x dash is -x and my y dash is y. So it's one of those things, it seems counterintuitive at the beginning, but you just have to remember when you're reflecting in the x, your y changes. When you're reflecting in the y, the x changes. If we were now just to do this problem right here, it says find the image of the point 1, -5 after a reflection in the x-axis. If we wanted to do this a long way, you would say, well, I have my original point, then I have my newly transformed point, and I know that x dash is going to remain the same because I'm reflecting in the x-axis, so that's just going to be x, and my y dash is going to be -y. So that means if I'm starting with 1, -5, it is going to end up being 1, 5, because it's going to be -1 times 5, so my answer is 1, 5. If it asked us for a reflection in the y-axis, if you wanted to do this really quickly, you're just going to say, well, if it's reflecting in the y-axis, that means my x value is going to change, so it's going to be -1, -5. Let's now keep on going. We're now going to answer this question, and we're going to do it the long procedural way. So it says find the equation of the image y equals x squared minus x plus 1 after a reflection in the y-axis. So we're going to do this the long procedural way. So we start off by writing this, then this, and then this. Then we rewrite it. Now, because we're reflecting in the y-axis, that means my x value is going to change, so x dash is equal to -x. Then we write that. Now I can say that -x is equal to x dash. Whoopsie daisy, that should just be y. Then it's going to be y is equal to y dash. Now remember, I now want to solve these for just x and y, so I'm going to have to divide this by -1, and I'll divide this by -1 to get x by itself. So that means I'm going to get x is equal to -x dash, and over here this is already done for me. Now I remind myself what the original graph looks like. It's y is equal to x squared minus x plus 1. Now into the y position I put y dash, And into the x position, I put negative x dash. So it's going to be negative x dash squared minus negative x dash plus 1. Now, this is where I would normally solve for y, but it's already done that for me. So all I have to do now is drop the dashes and see what I get. So I'm going to get y is equal to, now negative x squared is going to be x squared, because the negative is going to go away. Then here it's going to be plus x, then here is going to be plus 1. So my answer is going to be x squared plus x plus 1. That is going to be my answer. Let's now do the other one. So let's come down here, let's come do this one. All right, so you might like to pause the video and give it a go for yourself. So this is how you would approach it. Now I am reflecting in the x-axis, so that means my x dash is just x, and my y dash will be negative y. Then I'll go x is equal to x dash, negative y is equal to y dash. So this is already good. And then here I'm going to have to divide both sides by negative 1 in order to get this. Then I remind myself what the original graph is. Then I substitute my points in. So in the y I put negative y dash. And then I just put x dash here. Whoops. Now it's actually kind of pointless to put x dash in there because at the end of the day, nothing is going to change. It's just going to become x squared minus x plus 1. So it's kind of pointless doing that, but I did it nonetheless. Then what I want to do here, and now this is important, I want to get rid of this negative 1 here because I want y by itself. So what I'm going to do is I'm going to divide by negative 1 here, I'm going to divide by negative 1 here, and I'm dividing the whole thing by negative 1. So that means what I'm going to end up with is a negative here. So I'm going to end up with y equals negative x squared plus x minus 1. That is going to be my answer. Let me grab that. This is going to be my answer. Negative x squared plus x minus 1. Okay, so having now gone through those examples there, I want to talk about the shortcut method of doing this. And you probably noticed it when we were doing it, that when we have a transformation that is a reflection in the x-axis, what ends up happening is that we have negative the function. So we just have to put a negative in front of the function. And you can see that up here. So here we had a reflection in the x-axis. And what it ended up happening is we just put a negative in front of the thing, in front of the equation. As opposed to when we have a reflection in the y-axis, in that instance, what we do is we replace our x with negative x. We replace our x with negative x. And you can see that if we go up here, that's what we ended up doing, negative x, negative x. All right, so with that information, we can answer questions really quickly. So if it says find the equation of the image y equals the square root of x after a reflection in the x-axis, well, if we know that a reflection in the x-axis, we simply need to put a negative in front. We're simply going to go y is equal to negative the square root of x. And then over here, find the equation of an image of y equals the square root of x after a reflection in the y-axis. So what we would do here is simply go y equals the square root of negative x, just like that. So as you can see, because reflection in the y-axis, we just replace our x with negative x. And here you'd probably also have to make a bit of a mention of the fact that this is going to affect our domain. Our domain would have to be less than or equal to 0 here. If you just wanted kind of a visual representation of what we're doing here, let me just quickly show you. So we know that this right here is the square root of x. Whoops. Is the square root of x. If I had negative x, it's reflected in the x-axis. And if I have this, it is y equals the square root of negative x. You can see here that I would have to say that my domain is less than or equal to 0 in that case. Okay, let's keep on going. So here I have, yet again, y equals x squared and a reflection in the x-axis. So that means I just put a negative in front of this whole thing. Over here, I have y equals x squared again, but a reflection in the y-axis. So what that means is in my x position, I replace it with a negative x. So instead of x, I now have negative x. So that means I'm going to end up with this. Now this is different because now this is going to be x squared. So this is very important now. I have this and this as my answer. And again, let's just kind of get a bearing of what's exactly going on here. So always good to visualize what's happening. So if I draw this for a second, we know what y equals x squared looks like. It looks like something like this. And this right here would look like this. Y equals negative x squared. That's reflecting in the x-axis. This is my x-axis. If I was to reflect in my y-axis, if I was to reflect this in my y-axis, it would actually just end up being the same thing. And that's why it hasn't changed there. So again, if I were to reflect that in my y-axis, it wouldn't change anything. It would still look as it would look. All right, last two questions. Find the equation of the image of this after reflection in the x-axis. So what that means is I'm simply going to go negative this whole thing. Whoops. X plus 2 over x squared plus 1. So that means I'm going to be left with negative x minus 2 over x squared plus 1. Then over here, find the equation of the image of the same thing after reflection in the y-axis. So now every time I see x, I replace it with negative x. Plus 2 over negative x squared plus 1. Y is equal to negative x plus 2 over, that's just going to be x squared plus 1. So those are going to be my answers right there. This and this. And with that, we have come to the end of this lesson. Hopefully you found it useful and you feel confident with reflections. I'll see you in the next lesson.